Hello viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're gonna talk about GSLV Mark III. So let's dive right into it. Well, first we have to understand what the heck we are talking about. Same way India has PSLV, this is GSLV. So what does that mean? That simply means Geosynchronous Satellite Launch Vehicle. Basically, you can replace the G with P, that will become Polar Satellite Launch Vehicle. Now, this puppy was specifically designed because PSLV, while it's capable, while it's powerful, it's basically targeted at smaller satellites and low Earth orbit. This puppy is, on the other hand, is built for geostationary. That's the name, and you have to understand the satellite we sent on geostationary. Even though our electronics does allow us to make smaller components, we don't actually make smaller satellites on geostationary. Heck, it went opposite way. We are making even bigger satellite. But benefit of that is throughput is going YOLO. Basically, in 1990s, you would be really lucky if you get a geostationary satellite that is like around 10 Gbps. Now you can get up to 40 to 80 Gbps. So that is why we inherently need these satellites. These are not optional. These satellites are like backbone of many national systems, from weather systems to core communications to and all that jazz. So we have to have this is not a luxury or a choice. We have to have it. So GSLV Mark III allowed India to reach into a category where India can comfortably say, okay, 3 ton and up, we can send in geostationary. Because you have to understand that you may look at a rocket, let's say Falcon 9, and you're like, hey, 20 ton to low Earth orbit or 23 ton. Does not mean that it can send the same amount of payload to geostationary. That payload will go drastically low. So from 23, it can go down as low as 6 to 9 tons. So that's the whole point. That's why generally we have a bigger and heavier rocket for geostationary, and hence this. Now, the logic behind it is rather simple. PSLV is a workhorse. We launch the most amount of rocket is generally PSLV. Like if ISRO is doing any launch, you can be damn sure it's more or less PSLV. But PSLV was different. It's like a new market of small sats, so it was focused for that. So GTO was needed, and this was created. Now geostationary satellite orbits are getting heavier. Basically, we started with 1 ton, 2 ton. Now it's like 3 ton, 6 ton. Like we needed something to handle the load. On top of that, India in early 2000s started to realize sooner or later India has to reach a point where they has to do human manned mission, basically human mission to space, not to moon, not to Mars, but at least to low Earth orbit. Basically something like a space station kind of scenario. India has to do it. Now to do that, you can't directly go and build Saturn V. You have to build small systems, like how America did for Mercury project. Mercury, and then they went into Apollo. So same way, not even Mercury, even Gemini was before that. So India is also doing this same thing with GSLV Mark III. GSLV Mark III is also laying the foundation of India's human manned system. On top of that, India is slowly brick by brick starting to develop its own engine. We went from just buying every engine to okay, collaboratively developing engines, and then we are slowly moving into 100% indigenous engine development. Now engines are not something you can test on ground flat out. You can just do burn testing. Does it survive its own heat for few minutes? But you have to understand, like vacuum optimized nozzle, you fire that up in sea level, boom. So we have to have a rocket to test it. And not to mention, if you make a big one, you can't put a big engine on a PSLV or something like that. So newer generation of engine requires newer test bed. So this rocket will also act as a test bed scenario, where they're like, okay, if something is not too mission critical, they can test new fancy engines. So how the heck this works? Now you go to ISRO's site, which I have provided link down below. It will read as 3-stage engine. I'm like, and the photographs looks like it's a dual system. So what the hell is happening? It's doing something interesting. It's almost like how Soyuz rockets are working. It's doing parallel staging. What does that mean? That means when you fire the first stage, the solid booster, the main amount of liftoff gets from S200. S200 is the booster system, the biggest booster ISRO builds. So this puppy will lift up the rocket, but here's the central engine will not be on. So it's not like space shuttle engine or Ariane system. The core engine is off at this point. So whole liftoff and early few seconds are the thrust is directly coming from solid boosters. Once solid booster reaches their point where they're starting to deplete in performance, then the core engines are ignited. Now core has two liquid hypergolic system, and they will start to take off the main acceleration. At that point, solid booster would be depleted and it would be jettisoned. So that would be quote unquote first staging. Then the core will still run on for a few seconds, and then it will be depleted, and then this will be detached. And the third and final stage, which has basically C25 engines, which are basically liquid hydrogen and liquid oxygen cryogenic engine will fire. It's an open cycle engine, and this will put the payload into final orbit. That's why it has three engines. You have to be mindful of that. The solid boosters are only firing in basically solid boosters are responsible for the launch. It's not like space shuttle where the liquid engines are firing, but they do not have the oomph to do the launch. In this scenario, the liquid boosters are like shut off, so to say. So that's the working of it. It's kind of unique. Now, how many launches India have done with this? Well, 4. Now you're like, wait a minute, that number is a bit too small. The reality is that's why PSLV was built, because again, this is a big boy. We don't need big boy for everything. It's like not every job requires a tunnel boring machine. It's the same thing like that here. Now, the first mission that was done with this, the boilerplate, quote unquote, was basically Gaganyaan, India's manned mission project. Gaganyaan demo mission was done on this. Now, demo was basically fine-tuned for parachute deployment. So basically, send a capsule and figure out like does the parachute deployment works and all that. So again, it was a dummy mission, but they still managed to learn a lot of important lessons. And if any of you have followed any recent development with SpaceX Dragon capsule and Boeing capsules, parachutes are a ludicrously complicated system. So India testing that out is awesome, and that's also on first demo mission. And after that, it has 100%. So basically all 4 missions were successful. Now you may say, hey, that's kind of like calling 4 missions successful when you only launched 400%. But you have the GSLV Mark II was not that successful. GSLV Mark II had some teething issues, basically some technical faults, and some explosions have happened. So it was a very not very bright thing. And not to mention, we wanted a human mission, so this puppy has to live up to that 100% reputation. Because again, while we'll have a escape system, it will not. No country is stupid enough to build something like space shuttle. Everybody will build a emergency escape system, but we still have to reach a point where it's like, no, we got this. So having that all 4 being successful, it gives a certain level of confidence. After that, 2 main missions were done, which was the primary reason why this rocket was built. One of them was 3.4 ton, which is really big. Another was 3.1, still big. So you get the point. This was the main reason why this rockets were built. And then another final mission was Chandrayaan 2. So for Chandrayaan 2, they had to do special modification with the payload system. Now, what we can expect in the future? Now, it's a must-have for Gaganyaan mission. Flat out, India cannot have Gaganyaan mission without this. So this rocket has to be developed, and it has to be improved, upgraded upon, and has to be human certified. So it is the foundation of Gaganyaan. However, you have to understand, at this point in time, while ISRO is quite capable, still the run-ups is 2 primary limitations. Limitation number 1 is it's not production speed is not fast enough. So sometimes you could literally have a scenario where it's like we have to launch 4 satellites. This year we have only rockets for 3. So in those sort of scenario, India generally goes to ESA, European Space Agency, and asks them to do the launches. Again, it's expensive and tedious process, and that itself is not too much of an issue. But many times something worse happens. That is like we built a satellite, but it's too heavy for GSLV Mark III. That's a very problematic thing. So recently, like if you have following ISRO's news recently, you'll notice ISRO did a very recent launch with Ariane system. Why is that? GSLV Mark III, while powerful, still lacks a little bit of punch. So basically, if you can upgrade it to 10-20%, then India will be set. At that point, it will be like only production speed would be the limitation. Right now, our total capacity is the limitation. Like how heavy of something we can send into space, that is limited. So developing GSLV Mark III, or maybe even Mark IV, the newer version may be called Mark IV, that is very important to get independence, where they're like, no, we got this. Again, we may not be like the dominant launch provider, but at least we can take care of our own. That is very important. And another aspect that is under development right now as I speak to you is SCE-200. Basically, this is a kerosene and liquid oxygen engine. And now this puppy is built for power. It's not efficient engine. It's not designed for like, maneuverings and all that. This is like brute force engine. It's like F1 kind of engine. And this engine is supposed to replace GSLV's Mark III's stage 1. Stage 1 may, again, this engine is still in development, so we do not know the final aspects of that. It may replace the 2 engines with 4 engines and ditch the solid booster. That could also happen. So again, that is why I specified this is a test bed. So there is a very good chance we may see GSLV Mark III, Mark IV or GSLV Mark III version something else. So there's a lot of hope riding on this exact rocket. It's not a workhorse rocket, but it is a very important rocket for Indian Space Agency and India as a whole. So this was my presentation on India's GSLV Mark III. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.